Systems of nonlinear equations and two variables. So when they say non-linear, here they're saying that you can have equations where you may have x squared involved or x cubed or something like that, nonlinear. They had an image in the first page of the section of a dinosaur, and I forgot to bring my Godzilla. I have a Godzilla on my desk upstairs, and when I was a kid in the 70s, I was fascinated by Godzilla, all those movies, those monster movies. So my mother for Christmas, she bought me this Godzilla. I was probably like, I don't know, 6 or 7 years old, and she bought me this Godzilla. He was my height. He had a red tongue that stuck out, and I did what most boys did, back then. I tore it up. But anyway, um, I just thought that was cool. Recognize systems of nonlinear equations in two variables. Solve these nonlinear equations by substitution. That's the method that I use here. They talk about the third objective, to solve nonlinear systems by addition. I only use this guy, and that's the only one that I'm going to show you, and I think it's pretty easy. I think you enjoy it. Again, this section is also mechanical. Let's see. Here are my steps, methods to solving systems of nonlinear equations in two variables. Solve for one variable from one of the equations. When I say solve, you're not going to get like a number. This would be a variable expression is what I'm calling that. Substitute that variable expression into the other equation for that variable, and then simplify and solve. Solve for that variable. The cool thing here is that you may get more than one solution, which is pretty cool. Because, say, for example, you may have, here's the idea. You may have a circle, and it's being intersected by a line. So obviously, if I solve, I'm going to have two solutions where that line crosses a circle at 2 points. Okay? So that's the idea. Without further ado, let's just go ahead and look at some of these problems, right? So following the steps, solve the system by substitution. Look at both of the equations. Now, if one is a line and the other one is not, x plus y equal 1 is a line. Solve one of the variables in that guy. Okay? So, excuse me. So what I'm going to do is I'm going to solve for x. Now you can solve for y for that first equation. It doesn't matter. Everything still comes out to be the same. So here, x is equal to 1 minus y. Everybody see that? All right? That's step number one. Step number two, I'm going to take this is called the variable expression. I'm going to take x equal to 1 minus y and plug it in for that x there. So I have y is equal to x, which is 1 minus y. Since it's a binomial, I put it in parentheses. That's to be squared minus 11. Now here, step number three, just solve for the common variable, which is y. Right? So we're going to solve. So this is y is equal to, simplify that. This is 1 minus y to be squared. You remember you got to FOIL that. 1 minus y times 1 minus y. Right? So that's 1, first times the first. Outer times the outer is minus y. Inner times the inner is minus y. So I get minus 2y. The last time the last is plus y squared. So I have 1 minus 2y plus y squared. Then we have that minus 11 sitting over there. Well, since it's a quadratic, that is, it has a y square in it, I'm going to get everything on the same side. So I'm going to subtract the y on both sides. So I get here this 0. I'm going to write the y square first. This is minus 2y minus y. And then that 1 minus 11 is minus 10. So this is 0 is equal to y squared minus 3y minus 10. Hopefully we can factor. I need two numbers that when I multiply I get negative 10, but when I add them I get negative 3. Look at the factors of 10. We're thinking what? 2 and 5, right? So I'm going to put a 2 here, a 5 there. And which one is minus? The biggest one is minus because the result here is minus 3. And this number here is positive. That's set to equal to 0. So that means that y is equal to negative 2 and y is equal to 5. So check this out. Step number 4 says go back to step number 1. Step number 1, I had x equal to 1 minus y, right? So here, let y equal to negative 2. So this implies that I have x is equal to 1 minus a negative 2. That becomes 1 plus 2, that's 3. So the point that I have here is 3, remember x goes first, comma, negative 2. That's one of them. Notice I get two values for y. So also let y equal to 5. So this implies that x is equal to 1 minus 5, I get negative 4. So the point here is negative 4, comma 5. All right? And you see the points there. And so you'll put those here, right, in my math lab. All right, let's look at another one. Let's make sure we get it. Does that make sense there? Again, these are the steps that I'm following. 1, 2, 3, 4. I do that for every last one of the problems. Okay? See if I can work out two problems left here today that I can do, and don't have time to give you anything. Sorry. Because there's a problem that involves circles, and that's really cool. And I definitely want to show you that one. So we got this one here. That's the one with the circle. And then that one also has a circle. Well, that one has circles too, right? So pretty cool. So let me go ahead, because this one works just like the previous one. So let's look at this guy right here. So again, this is a circle with radius the square root of 74. And does the line cross it? Well, we don't know. We have to find out. So step number 1, I'm going to take the line, solve one of those variables. Here I'm going to just get x. X is equal to y plus 2. Does everybody see that from that second equation, right? So now what I'm going to do in step number 2, I'm going to take x equal to y plus 2 and plug that into this second, to that first equation, is x squared. So this is y plus 2 to be squared plus y squared is equal to 74. So from here, just solve for y. Right. So we FOIL that out. This is y squared plus 4y plus 4 plus y squared is equal to 74. This is 2y squared plus 4y plus 4 is equal to 74. Since they all have common, you can factor here, but the thing is you got to get everything equal to 0 because it's a quadratic. So let's subtract the 74 on both sides. So I have 2y squared plus 4y minus 70 is equal to 0. I have a common factor of 2, so just divide everything by 2. So I get y squared plus 2y minus 35. Make the numbers small. Make it light on yourself. That's what I do. Now factor. I need two numbers that when I multiply I get 35. When I add them I get 2. I'm thinking 5 and 7. 5 and 7. Right? One has to be negative, one has to be positive because of the setup here with the plus 2y and the minus 35. The biggest number has to be positive because the result is plus 2y. It has to be plus, that has to be negative. So I get y equal to 5 and y equal to negative 7. So let y equal to 5. This is step number 4. And I have here for step number 1, x equal to y plus 2. So I get x equal to 5 plus 2, that's 7. So the point there is 7 comma 5. Right? And then also let y equal to negative 7. And I get x is equal to y, which is negative 7, plus 2, x is equal to negative 5. So the point there is negative 5 comma negative 7. Does that match up? Negative 5, negative 7, yes, and 7, 5. I think I saw one where there was 2 circles. And so, do those 2 circles overlap? They might, in some kind of way. Let's see. I think I saw that one. It was that guy. No, that is the one. Yeah. Boy, that is spooky. Let's take a stab at that. I couldn't leave you. I can't leave you here. So step number 1, I'm going to take that first x squared and just get it by itself. X squared is equal to 2y squared minus 14. And then I'm going to substitute, replace this x squared in that second equation with this expression. So this is 3 times x squared, which is 2y squared minus 14, plus y squared is equal to 21. Here, solve for the common variable. So this is 6 y squared minus, what is that, 72, plus y squared is equal to 21. Let's subtract the, well, let's do this. This is 7y squared. I'm going to add the 72 on both sides. So that's, what is that, 93? $42. So this is 63. So divide both sides by the 7. So y squared, was that equal to 9? So that makes y equal to plus or minus 3. So there's 2 values for y. So here, let y equal to 3, go back to 1. I get x squared is equal to 2y squared minus 14. X squared is equal to, this is 2 times 3 squared minus 14. X squared is equal to 9 times 2, was that 18, minus 14, was that 4. So if I get x squared is equal to 4, what's x equal to? X is equal to plus or minus 2, right? X will be plus or minus. So I have 2 comma 3, and I also have negative 2 comma 3, all for that same y. Now, we got 2 values for y. Let y equal to negative 3. So if y is negative 3, then I get x squared is equal to, go back to equation, this first step, 2y squared minus 14. X squared is equal to 2 times negative 3 to be squared minus 14. X squared is equal to, that's 9 times 2, that's 18 minus 14. Again, I get 4. X is equal to plus or minus 2. So I have 1, there's a 2, and then negative 3. And then I have negative 2, negative 3. And you get 1, 2, 3, 4. Okay? Thank you. Do the homework for those two sections and tell me about it the next time we see each other.